Section 1.8, how to solve linear equation for the second degree equations. We discussed about the first degree inequality. First degree inequality when its power of x is 1. In that case, you have only one x, and like in this example, x is less than 1. That means numbers that satisfy this first degree inequality are all from 1 all the way to negative infinity. Now, when you're dealing with the second degree polynomial or second degree equations, then you have up to 2 answers. So if the equation is already factored, you see it as multiplication of 2 parentheses. If not, then you need to use the method of factoring and factor it into 2 parentheses. Now, on this example, to find the x value, we take x minus 1 equal to 0. In these examples, we take each parenthesis set it equal to 0. When you take these 2 parentheses and set it equal to 0, then you have 2 answers, 1 and negative 3. We label those numbers on the number line. The smaller one is negative 3 and then 1. And then you take a number, arbitrary number between 1 and infinity, any number, let's say 10. I want to know if I take 10 and substitute here for the x, is the outcome a positive or negative number? When I do that, 10 minus 1 is 9, 10 plus 3 is 13, 13 times 9 is the positive number. And then normally they alternate, or if I take a number between minus 3 and 1, like 0, and you substitute here, then you have a negative and positive. In these problems, you are looking for a positive numbers. So we don't want anything, we're looking for negative numbers, so we don't want anything here and there. So then all the x are bounded between 1 and minus 3. And if you don't have equality sign here, the final answer is the parentheses. However, if you have an equality sign, then you use the bracket for the final answer. This is the case. This is another problems, x2 less than 36. So what I do is when you want to solve it, first you have to bring the number to the left, like how you solve the equations. But x2 minus 36, 36 is 6 to the power of 2. To factor that, you are using this factoring formula. If you have difference of 2 perfect square, you could always break it into the conjugate or 2 sum and the difference of 2 variables. So in that case, x2 minus 6 to the power of 2 is multiplication of these 2. You take each parenthesis, set it equal 0. So there are 2 numbers. There are 6 and negative 6. So you label those numbers here. Again, you pick a number greater than 6, substitute in the original equations. That would make it positive and negative and positive. They normally alternate. In this example, again, we are looking for a negative number. So we don't want any number here or there. Now, we don't have equality sign again, so you have just the parentheses on both sides. So these problems discussed already are very similar. Look at this example. This example again, what if we give you an equation in this format? You have to factor it first. How do I factor it? This is a trinomial. You find 2 numbers whose multiplication is negative 5, and when you subtract is positive 5. And those numbers are 5 and negative 1. 2 numbers whose multiplication is negative 5, and when you subtract is positive 4. 5 and negative 1. You put in each parenthesis. Then you take each parenthesis, set it equal to 0. So the numbers or the answers normally have an opposite sign of what you see here, which is negative 500. We label those here. Again, we pick a number greater than 1. Any number between these 2, you test it. It's positive, negative, positive. We're looking for positive. This time, we don't want any negative sections. So there are 2 pieces of answers. 1 and infinity, negative 5. And then we are using letter of union to connect these. So in a case like this, since you're connecting these 2, you are using the union. Why do I use the bracket for 1 and negative 5? Because there is an equal sign here. Now these problems, again, first, before you solve the inequality, first you want to make sure that all the numbers are on one side. So before I do that, I'll take x plus 2 quantity square and multiply that, bring 36 to that side. Now I need to find two numbers whose multiplication is negative 32, and when you subtract is positive 4. Those are 8 and negative 4. So the numbers that we need to label are opposite 4 and negative 8. Again, the sign is negative. The original sign is the negative sign. So we are looking for the negative numbers. So in that case, we don't need positive. X is bounded between 4 and negative 8. Since there is the equality sign, both are bracket. This problem is very similar to that one. Bring 20 to that side. Find two numbers whose multiplication is negative 20. When you subtract, it's positive 1. You label. The original symbol is negative, so we don't want any positive numbers here. There is no equality sign, therefore it's a parenthesis. Two numbers whose multiplication is negative 40, when you subtract is minus 3. Very similar. In this one, since the symbol, the original symbol is greater than 0, we are looking for the positive sections. So we don't want anything in the middle. So there are two pieces here. There is no equality sign, so they take parentheses on. Now, these problems, why there is no solution? Because, when if you're using quadratic formula, let's say you want to solve this. First of all, if you want to use the factoring, you need to find two numbers whose multiplication is 11. When you subtract, it's negative 2. You cannot find such a number like that. Why not? When I use the quadratic formula, under the radical, determine whether there is answers or not. B squared minus 4ac is a negative number, so there is no real solutions. So what you have under the radical determine whether you have two solutions, one solution, or no solutions. If b squared minus 4ac is greater than 0, you end up having two answers. If it's equals 0, then 1, and if it's less than 0, then there is no real solutions. Now here I want you to understand the difference. These two problems, one is x minus 1 times x plus 3. The other one is in the fraction, x plus 3 is on the denominator. When x plus 3 is at the denominator, when you solve these two inequality, they all have a similar solution, but that at the end, we don't allow to put bracket for negative 3. If these two, they both have equal sign, but negative 3 is at denominator. So anytime your final solution has a number that makes the denominator 0, you cannot use the bracket. It has to be parentheses. So it has to be parentheses minus 3. Why? Because if you put a 0 here, if you put negative 3 here, that make it 0, and any number over the 0 is undefined. So in that case, let's look at these two examples. There are 3 parentheses, so the numbers is negative 3, minus 0.5, or half, and 1. The other one, these two are at the denominator. So when you label the numbers, when you label it, at the end, negative 3 and half cannot take the bracket. It has to be parentheses. Why? Because they both at the denominator. In case they are at the denominator, in case your x's are at the denominator, the final answer do not take any bracket for those two numbers. Not for one, just for these two. See, like I show it here. If one of the answer is 7, one is 7/5. Okay. And they do take a bracket because it's equality sign. But on this one, because 7 is at the denominator, when you solve it, you cannot put bracket for the 7. Here, it would be bracket is okay to have a bracket, but not for this guy. It has to be parentheses. So that's the only difference between these two problems. We'll just show it here on this example. Now, like in this one, you take a common denominator first, you combine these two, you simplify the numerator. The final answer is this. There are 3 numbers, 7, 3, and -1. You label those. Because the sign is greater than 0, we are selecting these two, okay? It's just a final answer for 3 and -1. 3 and -1, you have to use parentheses. Again, since this original symbol is positive, we don't want any negative sections. Yeah, we are taking these two. There are 4 answers, 0, -5, 6, and -6. Symbol is negative, so you are not taking positive section. Excuse me. So in that case, the final answers for 6 and -6, we are using parentheses. 6 and negatives do not take bracket. Now, these problems, we factor first. First, I multiply everything by negative. When I want to do the factoring, I always like to have the x2, the first term, I like to have a positive instead of negative. So from the beginning, I multiply both sides by negative, switch the sign. Then I find 2 numbers whose multiplication is -8, and when you subtract is -2. So these are the answers. Same thing here. When you multiply by negative, you have to switch the sign. You see that? For this problem, you are using the group factoring. Group factoring is if there are 4 terms, you break it into 2 groups or 2 first degree. Then this one, x2 minus 16, again is x minus 4 times x plus 4. It's a formula of the factoring. So these are the set of the answers. The last subject is domain and range. Think of the equation like this, y equal x plus 1. In this equation, any number for x, they always give you a value for y. Domain is the x value. You are allowed to substitute any value for x. You always have a value for y. So domain is all the real number. That's not the case in these problems. In these problems, I can substitute any number for x. I always have a value for y except 2. If you substitute 2 here, then it's undefined. So domain, which is x, is all the numbers except 2. So when we ask you to find a domain, means is there any number that you cannot substitute for the x? Because if you do, there is no value for y. Yes, this one. Domain is all the numbers except 2. When it comes to the radical, all the numbers greater than equal to 3 are okay. Because you understand under the radical, you cannot have the negative number. So if you substitute the number less than 3, let's say like 2. What is 2 minus 3? -1. Radical minus 1 is undefined. So anytime you want to find the domain for the radical problem, what you have under the radical, you have to take that and set it greater than or equal to 0 and solve it. That would be your domain. This one, because you have x2 and 4, it doesn't matter what number I substitute for the x, the outcome is always positive. So these are the domains. So x can be any number, because any number you substitute, the outcome is always positive. So you always have the value for 1. You cannot find any number that when you substitute, it give you undefined. See, because at the denominator, because it's x2 plus 4, any number you substitute for the x, since you raise it to power of 2 is positive. For the radical, the norm is you take what you have under the radicals that are greater than 0 and solve this inequality. See, like here, if you want to find the domain of the radical, what you have under the radical set it greater than equal 0 and solve it for x. That's how to find the domain of the radical and fractions.